Today, we're going to explore how to create more realistic skin shaders using specular highlights in Unreal Engine. Before jumping into the implementation, let's quickly review how Unreal Engine's default PBR shader works. Specular highlights occur when light reflects off a surface in the direction of the camera, which is why their appearance changes depending on the viewing angle. If you adjust the specular parameter in a material instance, you'll notice that without specular highlights, the skin can look flat and lifeless. Specular reflections are especially noticeable on smoother surfaces, those with lower roughness values. When roughness is low, highlights appear sharp and focused. When roughness is high, they become broader and softer. By fine-tuning these values, you can replicate the look of oily or sweaty skin for a more realistic effect. Let's switch over to the material editor and build this ourselves. In the previous video, we created Lambertian diffuse shading using the dot product between the light vector and the normal vector. For specular highlights, though, we'll use the half vector instead. The half vector is calculated by adding the light vector and the view vector, then normalizing the result. We'll take the dot product between the normal and the half vector. Compared to Lambert shading, which doesn't change with the camera angle, using the half vector allows the highlight to move with the viewer, creating more dynamic and realistic reflections. Unreal Engine's PBR shader uses the GGX model for specular reflection. To keep things lightweight, we'll simplify the model by using only the distribution term, skipping the Fresnel and geometry terms for now. This approach still allows us to control the intensity and spread of highlights using the roughness value. I've already prepared a material function for the GGX distribution. Let's bring it into the editor and double-click to take a look inside. You'll see two inputs, n.h and a2. For a2, we'll use the roughness value raised to the fourth power. Back in the material editor, let's create a roughness parameter, multiply it by itself 4 times, and connect it to the A2 input on the GGX node. Now preview the GGX node by setting the roughness to a low value to create a strong, focused highlight. Next, we'll combine this with the diffuse color from our Lambert shading and plug the result into emissive color for preview purposes. Rotate the camera in the preview, and you'll see the specular highlight tracking with the viewing angle. You should see the specular highlight reacting to the camera angle, exactly what we want. Let's apply this material to our character and try adjusting the roughness in the instance. Compared to Unreal Engine's default PBR, our specular might look a bit too strong. To fix that, go back into the material editor and add a specular color parameter. We'll multiply the RGB color with the specular output and use the alpha value to control the specular intensity. Now head back to the material instance and try tweaking the specular color. You can also use it to tint the highlight if needed. Together with the roughness, this gives you flexible control and helps create a stylized look that still behaves like real-world PBR shading. And that's it. We've finished implementing specular highlights in our custom material. If you found this helpful, don't forget to like and subscribe. See you in the next one.